Okay, good morning, students. So, in my last class, I think we had completed our discussion on the second module. So, today we shall continue our discussion on the third module. Okay, am I audible? Am I audible? Can everyone hear me? Okay.
Yes, sir.
So, this is a very important aspect of the third module. That is your structural geology and rock mechanics. Okay. So, this module comprises of the structural aspects of the rocks, like your outcrops, dip, strike, fold, fault, joint, unconformities, and how they influence the engineering products and structures like your dams, tunnels, slope treatments, ground improvements, and also how do you recognize the structures on the field. Yeah. And also the rock quality determination and rock structure rating, along with the geological site characterizations like the dam foundations, the rock foundation treatment for dams, reservoirs, heavy structures, and the grouting methods, and also the rock reinforcement. Okay, so finally the tunnels and their applications in the site investigations, and we have discussed on the coastlines and their geological considerations, engineering considerations. So what are geological structures? So geological structures are those which are dynamically produced patterns or arrangements of a rock or a sediment that result from the forces within the earth. Okay, so these are the ones which are produced as the rock changes the shapes, their orientation in response to the stresses that are being applied. Either the stress may be applied horizontally or it may be applied vertically. Okay, so the study of these shapes, the arrangements, and the interrelationships of the bedrock units and the forces that cause them is called as structural geology. Okay, it's a branch of geology which deals with the study of the structural aspects of the rocks, like the shapes of the rock, the arrangement of the rocks, the interrelationships of the bed units or the bedrocks, how they are arranged, what are the forces that are responsible for the deformation that are being caused within the rock. All these aspects will be studied under the geological structural geology. Okay, so coming to the stress and strain. So as you have to be studying the stress and strain in your the strength of materials, SOM classes, is it not? Stress is nothing but a force per unit area. Okay, strain is change in shape or size in response to the stresses. Stress means it is a force per unit area, that is force applied per unit area, and strain is a change in size or shape in response to the stresses. Okay, so there are three basic types of stresses, that is compressive stresses, tensional stresses, and also the shear stress. Okay, so strain, it is one where the structures are produced that are indicative of a stress and its rate of application, as well as the physical properties of the rock or the sediment that is being imposed under stresses. Okay, so coming to the tensional stress, it is that type of a stress which is applied from opposite side, that is away from the center at the same time. Okay, so the stresses that are being pulled apart from a single point, that are being pulled apart from the center on their opposite directions. Okay, shearing stress is the one which is directed, oppositely directed forces which are acting parallel to each other. Okay, so coming to the normal strain, it results in the displacement of the particles along the line of force, and also the shear strain is the one which results in the displacement of the particles at right angles to the line of forces. Okay, so coming to the rock responses to the stress and strains. So there are three important ways the rocks behave to the stresses and strains. That is, three types of deformation do occurs. One is elastic deformation, a ductile deformation and a brittle deformation, which is again dependent on the amount and rate of stress that is being applied, the type of the rock, and also the temperature and the pressure. Okay, so these are the three important factors that are being very important for the deformation of the rocks, that is elastic deformation, ductile deformation, or even the brittle deformation. Okay, if deformation of the materials return to the original shape after the stress is being removed, once the stress is being removed, if the particles which are being deformed initially comes back to its original position, then they are called as they are behaving elastically. Okay, if the materials do not return to the original shape even after they're being deformed, okay, the particles, if they do not return to their original shape after they're being deformed, they're called as ductile deformation. Or even the, if the particles breaks, if the particle breakdown or the permanent rupture or the deformation of a rock takes place permanently, the breakdown of the rock takes place permanently, then it is called as fracturing or brittle deformation. Okay, so ductile deformation is the one where it bends in form of plastic waves. Okay, so you have applied some stresses on a beam, so it has gone down. Once the stress is being applied, if it comes back to the original position, then you say it is the elastic deformation. Okay, if you have applied stresses on a rock, it has gone down, and once the stress is being removed, it will never come back to its original position, but it remains in that position itself. Then it is called as ductile deformation, which is plastic deformation. So when stress is being applied, if the particles break down, then it is called as brittle deformation. Okay, so these are the very three important forms of the deformations. So this question will always arise in the examinations. Okay, write a note on deformation of the rocks. That is your deformations. Okay, structural aspects, how the deformation takes place. Okay, so these are the three ways by which rocks will deform. One is elasticity, that is the particles comes back to its original position once the stress is being removed. Okay, I'll demonstrate to you this very practically. Okay, don't drop in your attendances now. Okay, see here. So this is one example for your deformation. Here you can see this is one form of your rock that is being applied to a stresses. If you assume this as a particle that is being applied to a stress, if it breaks down, you have applied the stress on from the top, okay, it has bent down, okay. After you remove the stress, if it returns back to its original position, so this is the stress that is being applied, you have removed the stress, it is coming back to its original position. So then it is called as a what? Deformation. Okay. So if you apply the stress and it after the removal of the stress the particle remains intact in this portion itself, then it is called as a plastic deformation. After you apply the stress, if the particles break down, it is called as a brittle deformation. Okay, so these are the three important ways by which you can see the deformation of the particles. I hope you understood with the deformations. Okay, elastic deformation, plastic deformation, and the ductile deformation. So coming to the components of the deformation, what are the four components of the deformation? We have got translation, rotation, distortion, and the dilation. Translation is movement from the initial location. From the initial location, if the particles move to a final location, then it is called as translation. Rotation means it is spinning of the particles about its own axis. Okay, so distortion means it is change in shape. Particles are displaced within a body, and dilation means it is change in volume. So here you can see how the compression, tension, and the shearing forces act against one another. Okay, when the particles are being subjected to compressive forces, what happens is the forces are being applied on both the sides. Okay, the forces are being applied from both the sides. What happens is the folding of the rock strata takes place. Particles are subjected to folding. Okay, so the particles are being subjected to compression from both the sides, which results in the folding of the particles. Okay, even the faulting of the particles may also take place. The particle may move along against one another. Okay, when the force is being applied from both the sides, when the force is being applied from both the sides, the particles, it results in either the folding of the particles or the faulting of the particles may take place. What happens in case of tensional forces? So in case of tensional forces, so there is stretching of the particles all along the sides. All along both sides, the stretching of the particles takes place, where what happens is the stretching causes the thinning in the center area. Okay, the stretching what happens is it causes thinning in the center of the rock body, which again results in the breakdown along the fault plane, which again results in the faulting. So what happens in shearing is that there is movement of the particles opposite to each other. One moves in one way and another moves in opposite direction. So again it results in the faulting. Okay, only in the case of compressive forces there is folding that occurs. In the case of tensional and shearing forces, always it results in the form of faulting itself. Okay, so coming to the structures and the geological maps, the rock structures are determined on the ground by the geologists who observe the rock patterns, which are called as outcrops. So the outcrops are the places where bedrock is exposed on the surface. So the geological maps are the ones which are using the standardized symbols and the patterns to represent the different rock types and the geological structures like the tilted beds, joints, faults, and the folds. Coming to the orientation of the geological structures, So geological structures are most obvious in sedimentary rocks. Most probably. Many a times what happens is these geological structures of the faults, even the folds, are always at joints and unconformities also. Joints may be seen in some of the igneous rocks, but these unconformities, the faults and the folds are a very common aspect in the structure of sedimentary rocks because they are the one which have stresses which have altered their original direction of inclination or orientation. Okay, so the tilted beds, the joints, and the faults are the planar features where the orientation is described by a strike and dip. Okay, so coming to the strike and dip, strike is a compass direction of the line that is formed by the intersection of an inclined plane with an horizontal plane. Okay, so the angle of the strike is the direction of the rock which has moved in which direction. Okay, it is a line that is formed by the intersection of an inclined plane and a horizontal plane, that is vertical plane which meets the horizontal plane which determines the strike of the rock, and the dip is the one which determines the angle that is being created by the rock at which the plane is oriented. Coming to the fundamental structures, there are three important fundamental types of geological structures. One is the bed contacts, another one is primary structures, and also the sedimentary secondary structures. Okay, so bed contacts are the ones which are formed by the contact of the two rock types. Okay, so bed contacts are the one wherein the rock types are being formed in two important ways. Two beds are contacted or joined or which contact one against one another. Primary structures are the one which are produced during deposition or the replacement of the rock body, and secondary structures are the ones that are produced by deformation and other process after the rock is being formed. Coming to the bed contact. So the boundaries which separate one rock unit with the another is called as a bed contact. There are two types usually. One is a normal conformable beds and another one is unconformable contacts or the unconformities. So conformable beds, what happens is it is a horizontal contact between two rock units with no break in deposition or the erosional gaps. Okay, you can see it is continuously formed without any breakage in the time of deposition. Okay, so there is no significant gaps in the geological time. Example is a book cliffs in the central Utah. You can see here it is a continuous deposition of the rock beds one above the other without any gaps. Okay, without any erosional gaps is called as a conformable beds. You can see the continuity of the bed structures. You can see the continuity of the bed structures. Okay, so this represents a single bed which is continuous in nature without any breakage in between. Coming to the unconformable contacts, it is the erosional surface that represents a significant break in deposition. Okay, whenever there is deposition being taking place, there is erosion of one which represents a break in deposition. Okay, so there are three important ones. One is angular unconformity, disconformity, and a non-conformity. So angular conformity is a one wherein the bedding contact which discordantly cuts across a boulder strata. So here you can see discordance means the strata are at an angle to each other. You can see this is boulder rocks. A is a boulder rock where and along which the B is being making a angular contact. Okay, A is a common A feature which is a boulder rock. Okay, B is a newer rock which is making a angular contact. A is a older rock, B is a newer rock which is making an angular contact. Okay, so this type is called as a angular unconformity. You can see here this is a older rock upon which there is another rock which is making a angular inclusion. Okay, angular intrusion, angularly making an angle. It has moved along the plane which is resting on a boulder rock at an angle. Okay, so such type is called as angular unconformity. So what happens is in angular unconformity, the sediments are deposited one above the other. So it is subjected to compressional forces on either sides and also from the bottom, so which results in the formation of wavy undulations. Okay, so once the marine water increases or the marine water is being intruded into the wave like angular fold, it removes the top surface. Okay, so what happens is here, so the top surface is being removed, is being deposited by the new layer of the sediments which are being brought down from the marine transgression of the water, leaving behind the angular sediments at the bottom. Okay, so initially the sediments are being deposited one above the other, so there is compression that is being taking place on the either sides. This compression from the bottom also results in the wave-like pattern of the rock that is called folding. Okay, folds are being created. So this folds, what happens is once the water intrudes into the folding area, it brings along with them the newer sediments. Okay, so the top surface is being removed and it is being deposited with the newer sediments, leaving behind the older sediments at the bottom. The older sediments are always usually angular in nature. Okay, so this is one way how the angular unconformity will be formed. Okay, coming to discontinuity, it is a erosional gap that is being found within the rock units without any angular disturbances. Okay, so here you can see this is a older rock. Okay, so this is a older rock, this is a newer rock. In between there is some new rock units, but here there is no angular disturbances, but the erosion has taken place and that erosion has led to deposition of the newer sediments. Okay, here also you can see this is a older rock. Okay, the older rock has assumed the erosion has taken place in the older rock, newer sediments are being deposited here. Okay, newer sediments are being deposited. Okay, newer sediments are being deposited, which results in the formation of a discontinuity. Okay, so it represents a gap between two rock units, but here the gap will not be having any angular discordance. Okay, examples are the fluvial channel cutting into the underlying sequence of a horizontally bedded deposits. Okay, so coming to the non-conformity, so it is a sedimentary rock which is being overlying a igneous or a metamorphic rocks. Okay, so here at the bottom what happens is either the bottom or the basement comprise of the igneous or metamorphic rocks or even a sediment rock upon which either sediment rock may arise or a igneous or a metamorphic rock may arise. Okay, so one will be a bottom part, that is your sediment rock will be at the bottom part. If sediment rocks occupies the bottommost part, then the topmost part will be overlain by either igneous or metamorphic rocks. If igneous or metamorphic rocks have taken the bottommost position, then it will be the top portion will be overlain by the sedimentary rocks. Okay, so these are the non-conformities. So I think I'll stop my discussion here. If you have got any questions, you can ask me now. From next class, I'm going to continue on the folds and other aspects. If you have got any questions, you can raise your hands. If you have got no questions, drop in your attendances. We shall continue discussion next class. Thank you.